Good morning to all my fantastic fours out there. Lovely to have you with me again. I do enjoy this part of the day. I would enjoy it more if we were in a classroom together, but I guess this is the way it is for now. I've been going on about the importance of mental arithmetic, and as we started yesterday, we're going to start with a daily mental arithmetic, just 10 to get our brains sharp and hopefully hone some of those skills. A reminder that if you have any questions, anything you'd like to go through, anything you want to share with me, grade 4 at WorksheetCloud.com. You can find that link on the page. And after the lesson, click on the link above to do the worksheet, just to make sure that you've mastered what it is that we do today. On the next slide, I have 10 questions, mental arithmetic, the sort of things that you expect to be able to do in your head. I'm going to give you 40 seconds to do that. That's 4 seconds per problem. Please make sure you have pencil and paper. If you don't, rush off and get it now, or pause the video and go and get it quickly. A reminder, you don't need to write down the questions, just the answer. And also a reminder that getting things right is more important than completing all of them. So it's better to just get through 5 and get all 5 right than it is to go through all 10 and only get 3 right. I hope you are ready. 5, 4, 3, 2, 1, go. Halfway there. Stop wherever you got to. That's all right. Remember, it's not really about how many we got right or wrong. Of course, we'd love to get all of them right, but it's more about the practice of doing this, so that when you're doing this in a test at school, when it counts, that you're going to get it right. Okay, let's go through the answers. You'll notice some patterns. If you don't, that's okay. These should all eventually become sort of things that stick in your head that you're so good at that you don't even really need to think about it before you have the answer. So 14 minus 7 is 7. If you got it right, give it a tick. If you got it incorrect, just put the right answer next to it. So 14 minus 7 is 7. 14 minus 6 is 8. 14 minus 5 is 9. 13 minus 8 is 5. 13 minus 9 is 4. 17 minus 7 is 10. 17 minus 8 is 9. 15 minus 8 is 7. 15 minus 7 is 8. And 18 minus 9 is 9. I hope you got those. If you didn't keep up, you can always go back in the video and just rewatch it just to check that you got the answers right. So, something completely different today, the divisibility rules of 2, 3, 4, 5, and 10. There are nice divisibility rules for 6 and 9 as well, but I'm going to teach you those this year, maybe for next year. And there are also tricky ones for 7 and 8, which actually are more difficult to the point where I'm not sure that there's a lot of value in it at this stage of your schooling. So we're going to look at the divisibility rules for these. And when I say divisibility rules, it's little tricks that we can use to check if a number is exactly divisible by 2, 3, 4, 5, or 10. So in other words, does 2 go into it exactly? Does 3 go into it exactly? Does 4, does 5, or does 10 fit in exactly? And then we're going to use those, just to recap factors. We used our factor trees. I'm going to use them again. And we're going to do the factor trees using our divisibility rules to check whether something goes in exactly, before we actually go and look for how many times that is. All right. The divisibility rule for 2 is basically if it's even, it's divisible by 2. And a reminder what your even numbers are. Any number that ends on a 0, a 2, a 4, a 6, or an 8 is divisible by 2. So all we've got to do is, doesn't matter how big the number is, all we've got to do is look at the last digit. Oh, I made a mistake here. I see that it says, does 5 fit exactly into that? And it was supposed to be 2. I think I mixed up my sheets when I was doing that. So that should be over here, does 2 fit exactly into 208? We can ignore the 200 part. All we need to do is look at the 8, and because it's an 8, 0, 2, 4, 6, or 8, we know that 2 fits in exactly. And so yes, the 2 fits exactly into 208, not 5, 2. Let's look at the divisibility rule for 5. You'll notice that I'm not going in order 2, 3, 4, 5, 10. I'm going in order of how easy they are. So this one's very easy. Basically, if it ends on 5 or 0, then it's divisible by 5. So I'm sure that you've noticed that when you do the 5 times table, every number in the 5 times table ends in either a 5 or a 0. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. They all end on either a 5 or a 0. So that's the check. If it ends on a 5 or a 0, then it's divisible by 5. So 5 goes in exactly. So if I was looking at number 230, all I've got to do is look at the last digit, which in this case is a 0. It ends on a 0, which is either 5 or 0, so 5 fits exactly into 230. So when I'm looking at divisibility rules, I'm not actually having to do the division. I'm just looking to see how many times, or I'm just seeing if it can fit in. And if it can, then I can check how many times. Divisibility rule for 10 is probably easier than 5. If it ends with a 0, then 10 fits in exactly. So can it be as long as it is? All you've got to do is look at the last digit. If it's a 0, then 10 fits in. And you might have noticed that in the 10 times table. All of them end with a 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. All of them end in 0. So if it ends in 0, 10 fits in. So let's look at example. Does 10 fit exactly into 235? Does it end with a 0? Nope. So the answer is no, 10 doesn't fit in exactly. So we've done 3 rules so far. With 2, we just needed to see it ended on an even digit. With 5, it ended on either a 5 or a 0. And with 10, it ended on a 0. Now we look at a slightly more complicated one, but again, not too difficult. If the number formed by the last 2 digits is divisible by 4, then the whole number is divisible by 4. So we only have to look at the last 2 digits. So if we were looking at 232, we just look at the 32 part, the last 2 digits. And what we've got to check is, does 4 go exactly into 32? So 4, 8, 12, 16, 20, 24, 28, 32, it fits exactly in. So that means that 4 fits exactly into 232. And it could be 1232 and 4 would still fit exactly, because all we've got to do is check the last 2 digits. And if 4 fits in there, then 4 fits exactly into the whole number. So a little bit more difficult, especially when you get to something like 196, then you've got to know, does 4 fit into 96? But with practice, you'll be able to see which numbers it fits into. Divisibility rule for 3, the most difficult one that we're going to look at for today. It's not super difficult, but let's have a look. So if the number formed by the sum of the digits is divisible by 3, then the whole number is divisible by 3. That's sum of the digits. That sounds complicated. It's not. Sum means adding up. So what that means is, if you add up all the numbers in the number you're looking at, and that number is divisible by 3, then the whole number is. So let's look at an example to make that clear. Does 3 fit exactly into 234? Well, now we've got to add up. We've got to add up the digits 2, 3, and 4. So 2 plus 3 is 5, plus 4 is 9, and 3 fits into 9. So that means that 3 fits exactly into 234. So because it fits into the sum of the digits, it means that it fits into the whole number as well. So then we could go and check how many times. Let's work some examples. All right, so I've set this up as a table. What I'm going to do is put some numbers in on the left, and we're going to check whether they're divisible by each of the things. So let's start off with something small, something that we can get our teeth into. Well, let's see if 2 fits in. So just to remind you, the divisibility rule for 2 is, does it end on 0, 2, 4, 6, or 8? Is it even? Well, it ends on a 2. That's all I had to look at. So the answer is yes, it is divisible by 2. We're next going to look at 5. So for 5, we had to check if it ends on a 5 or a 0. Well, 2 is not 5 or 0, so the answer is no, it doesn't fit in exactly. And for 10, we ask ourselves, is the last digit a 0? It is not, and so 10 does not go into 12 exactly. I know that it's probably very obvious to you with 12 as the number we're starting with that it didn't fit in, and perhaps the other two are obvious as well, but we're going to practice with smaller numbers and then slowly move to bigger numbers. So we need to check for, let's do 4 next. We need to check if the number formed by the last 2 digits is divisible by 4. So in this case, it is only 2 digits. So we've got to look to see if 4 goes into there. So 4, 8, 12, it does. And so that means it is divisible by 4. When we've got to look at 3, we need to add the digits together and find out what that gives us. So 1 plus 2 equals 3. 3 is in the 3 times table, so then it is divisible by 3. So we can see without working it out, although this one was quite simple, that 2, 3, and 4 all fit into 12. The next number we're going to look at is slightly bigger. We're going to look at 35. So we're going to use the same order. Does 2 fit in? Well, does it end on 0, 2, 4, 6, or 8? It does not, and that means without working it out, we know that 2 doesn't fit into it. Does it end on a 5 or a 10? A 5 or a 0? It ends on a 5, and so that means 5 fits in. Does it end on a 0? It does not, which means 10 does not fit in. Looking at 4, is the number formed by the last 2 digits divisible by 4? 4, 8, 12, 16, 20, 24, 28, 32, 36. So 35 is not in the 4 times table, and so it's not divisible by 4. Let's add those 2 digits together. 3 plus 5, that equals 8. 8 is not in the 3 times table, so 35 is not divisible by 3. Let's look at 36. Does 2 fit in? We just got to look at the last digit. Is it a 0, 2, 4, 6, or 8? It is, so it's divisible by 2. Is the last digit a 5 or a 0? Nope, so it's not divisible by 5. It's not a 0, so it's not divisible by 10. Let's have a look at 4. Let's look at 36 and see if 4 goes in there. 4, 8, 12, 16, 20, 24, 28, 32, 36, 36. Yes, it is. So it's divisible by 4. Times tables, mental arithmetic, basis of good maths. Is it divisible by 3? 3 plus 6 is equal to 9. 9 is in the 3 times table, so then 36 is divisible by 3. Is our next digit, next one. Does it end on a 0, 2, 4, 6, 8? Yes, it does. Does it end on a 5 or a 0? Yes, it does. So 5 goes in. It ends on a 0, so 10 goes in. Let's have a look at 4. Well, 40 is 10 times 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. It's 10 times 4, so it does fit in exactly. 4 plus 0 is equal to 4. 4 is not in the 3 times table, so the answer is no, it's not divisible by 3. shift up a little bit. I have a couple more to go, 3 more to go actually. So 60. Let us see. Well, it ends on a 0, so 2 fits in. Ends on a 0, so 5 fits in. So does 10. 4. This is where I'm going to use, or show you a little bit of my thinking and a little bit of a trick. So I knew that 4 went into 40. So let me see if 4 goes into 60. Well, it's 20 more. And if 4 went into 40, if 4 also goes into 20, then 4 will go into 60. Because 40 plus 20 is 60. So let's check if 4 goes into 20. 4, 8, 12, 16, 20. So it does. So it goes into there 5 times, it goes into there 10 times. So in total, it will go into 16 15 times. You didn't need to work that out. All we needed to do was to check that it did go in. Pardon me. Let's have a look to see if it's divisible by 3. 6 plus 0 is equal to 6. 3 goes into 6. Here we go. It is divisible by 3. So in this case, 60 is divisible by all the numbers we looked at. Getting a little bit bigger. Second last one, 120. Does it end on 240? Yes, it ends on 0. It's divisible by 2. Ends on a 0, divisible by 5. Ends on a 0, divisible by 10. That's a tricky one. Well, not really, because all we've got to do is to check whether 4 goes into 20, because we look at the number formed by the last 2 digits. So 4, 8, 12, 16, 20 goes in 5 times. It does go in, that's the important thing. So it is divisible by 4. For 3, we're now going to add all the digits together. 1 plus 2 plus 0. 1 plus 2 is 3 plus 0 is still 3. 3 is in the 3 times table, and so 120 is divisible by 3. Last one, we're going to move the rules off the page. I hope you'll be able to still remember which one. By now, I think so. So we've got 324. So now we've moved into big numbers, and I hope you'll be able to see that this is where divisibility rules become quite handy. So only have to look at the last digit, 2 goes in. Not a 5 or a 0, 5 doesn't go in. Not a 0, 10 doesn't go in. Let's look at what's formed by the last 2 digits. 24, 4, 8, 12, 16, 20, 24, 4 goes in. So 324 is divisible by 4. Let's add 324 together. 3 plus 2 plus 4 equals 9. 9 is in the 3 times table, so it's divisible by 3. So we can see that by knowing our divisibility rules, we can check well in advance to see if something will go in. So what I wanted to do now is just go back to our factor trees, which we did before, and you look at some factor trees and how we can use the divisibility rules to check whether things will go in, and that will help us with divisibility with factor trees. So there are quite a few places where knowing how to use your divisibility rules will help you in maths, but quite a few of them are still concepts or ideas and things that you haven't learned yet. So factor trees is one which we will use, and which you will use the divisibility rules for, or you can. And it's also one that we've done already. So I thought it was a good opportunity to revise. So I'd like to find the factors of 32. So I hope you did this lesson with us. If not, factors are the numbers that fit exactly into 32. So I want to find all of them. What I'm going to start with is 1, because 1 went into everything. And 1 times itself gives the answer. So 1 times 32 is 32. So both 1 and 32 fit exactly in. All right, the next thing I want to do is I'm going to look to see if 2 goes in. And this is where I'm using my divisibility rule of 2 to check. So I can see that 2 fits in. So I know that 2 fits exactly in. and the 2 will times by something. So I can work out how many times. I can count in 2s until I get to 32. Whew. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That's 16. We are going to do division, and I will show you how to use that to make your lives a bit easier, but not today. Then I'm going to check my divisibility rule for 3. So remember, for 3, I needed to add these 2 digits together. 3 plus 2 is equal to 5. 5's not in the 3 times table, so 3 is not going to fit in. I look at 4. What I need to do for 4 is to check whether the number formed by those 2, in this case, it's the whole number, so whether 4 goes in. So 4, 8, 12, 16, 20, 24, 28, 32, it goes in. And if you were paying attention to my fingers, you would see it goes in 8 times because I got to 8 on my fingers. Incidentally, I don't need my fingers. I'm just using it so that you can follow my thinking out loud. What else did we need to check? Well, 5's definitely not going to go in because it doesn't end on a 0 or a 5. Neither will 10. Let's check. We don't have a divisibility rule for 6, but if 3 doesn't fit in, 6 won't either. That's it. And so if we write them down, we've got 1, 2, 4, 8, 16, and 32 as the factors. Let's do, we do still have time, let's do 35. So I always start with 1 and myself, or 1 and the number that would be there in the trunk of the tree. Let me check for 2. Doesn't end on a 0, 2, 4, 6, 8, so not going to be divisible by 2. Don't have to work it out. 3, if I add, wrong color. If I add 3 plus 5, I get 8, which is not in the 3 times table, so it's not divisible by 3. The last 2 digits are not in the 4 times table, so that also won't fit in. 5, well, it ends on a 5, so we know 5 fits in. So 5 times what? 5 goes into there 7 times. And in fact, that's all that fits in there. So we can now write our factors down underneath. 35 has the factors 1, 5, 7, and 32. I have 2 more for you. The next one is 60. And 60 was one of those numbers that we had divisibility rules. We had used, if you remember our table, 60, we had all of them fitting in. So we know, if you remember, we'll be able to use all of them. So first up, I'm going to start with 1 and the number in the trunk. It ends on a 0, so 2 fits in. So that means 2 and 2 times 30. 6 plus 0 equals 6. 3 goes into 6, so 3 goes into the whole number. So I know 3 goes in. 3 goes in 20 times. 4, we did actually do that one. We know 4 goes in. 4 goes in. 4 goes into there 15 times. I'll work that out on the side for us. I'm not going to go back for it. We know 5 goes in. 5 goes into 12 times. We know 10 goes in there. And then the next one that would go in would be 12, which we already have. So there we go. That's it. That's quite a few factors, but let's write it down. So 60 has the factors 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Lots of factors in 60. Let's move a little bit across so we can fit in the last one, which is 144. I always start with 1 and the number in the trunk, 144. Then I'm going to check for 2. I can see it ends in a 4, so I know 2 is going to go in. I don't have time to show you the working out, but I do know when we do division, you'll be able to work that out quite easily. So 2 goes into there 72 times. If I add 1 plus 3 plus, 1 plus 4 plus 4, it gives me 9, so it's in the 3 times table, so 3 goes into there. I'll show you the division quickly on the side, or just underneath. We will come back and do this, but what I'm going to ask myself is, does the 3 fit into 1? It does not. Does 3 then fit into 14? 3, 6, 9, 12. Well, it fits in. There's some leftovers, but it fits in. So it fits in 4 times. And I used 12, there were 2 left over. So now I ask, does 3 fit into 24? It fits in 8 times. And so then I know that the answer to this 3 times 48 gives me 144. Let's check 4. 4 is green. Does 4 fit into 44? It does. It's 11 times 4, so we know 4 fits in. How many times? So 4 goes into 125, 36. Don't worry how I work that out. When we do division, it will become easier for you to do it. I was doing it in my head, but you'll be able to work it out properly. Well, we know 5 doesn't go in because it doesn't end on a 0 or a 5. We know 10 doesn't go in. All right, there are other factors, but these are the ones that we could practice with the rules that we've learned today. And so I'm going to leave it at there. 6 goes in, 12 goes in. There are a few others that go in as well, but I'm not going to go into each and every one of those right now. Okay, but you can see how knowing the divisibility rules can help you with your factor trees. So I hope that you remember these divisibility rules and you'll be able to use them. There are definitely some more times in the future where you'll be able to use them as well. That's the end of today's lesson. If you have any questions, grade 4 at WorksheetCloud.com, and after the lesson, just click on the link above, do the worksheet, and just make sure that you've grasped the divisibility rules that we did today. I hope to see you again tomorrow. Have a lovely day, grade 4s. Goodbye.